the title of his talk is a discussion support system using neural language model, preliminary report. Okay, so please welcome Mamoru Yoshizoe. Okay, thank you.
Okay, thank you. Can you hear my voice? Yes. Can you see my slides?
Yes, thank you.
Yes. Okay. Hello, everyone. My name is Mamoru Yoshizoe from Ritsumeikan University in Japan. I'm glad to have the opportunity to present this presentation. I'd like to talk to you about the discussion support system using neural language model preliminary report. Okay, this is background. The internet and science technology is growing up, and society is also becoming more globalized and complex. Accordingly, it is growing diversity of values. And then differences of values cause a conflict called framing. For example, we can post our minds, ideas to website or SNS such as Twitter, Facebook, and so on. And many people can check them. If the post has very sensitive or inappropriate content and other people feel sick against it, they will criticize the person who posted it. In some cases, the people may be attacked by aggressive replies. To prevent this framing problem, we are often required to consider or respect the values of other people's thought. But it is not easy to sense them since we tend to think within our scope of knowledge, experience, and imagination. Additionally, with the development of service on the internet, we tend to separate from information that differs from our perspective. And we tend to deal with information which is familiar with our interests or our belonging communities. In this presentation, I introduce our discussion support system, which gives a stimulus and awareness. Okay. Well, what are values? For example, there is a chocolate, and there are some people who like chocolates and who don't like chocolates. We think that this like and dislike are based on each sense of values. So in the other words, values affect that we think the objects like or dislike. However, these values are invisible for us, so we have to visualize or put this feeling into words. Next, how do we recognize the values? People who like chocolates, they imagine chocolates healthy, delicious, sweet, nutritious, and more positive image, and they say that I like chocolates. On the other hand, people who don't like chocolates, they imagine chocolate dental calories, not tasty, get fat, high calories, etc. And they say that I don't like chocolates. Like this image, we imagine many things for the object. I consider that finding out values from the structure of the word network. In this slide, I show about word co-occurrence network. The co-occurrence network is a visualizing method based on the word's co-occurrence and frequency. For example, in the left, sentence A is the apple is red and sweet fruit. This sentence consists of 4 content words: apple, red, sweet, and fruit. They co-occur each other in this sentence A. And in the right side, sentence B is apple is round in shape. This sentence consists of 3 content words: apple, round, and shape. And they co-occur each other in this sentence B. The word and co-occurrence are represented by node and edge in the network. By accumulating many sentences, the network is constructed. In the previous example of the chocolate, we can construct the network like this image. And then when we see it, we can recognize the other people's value and thoughts. And using word coherence network visualization, we developed the group discussion support system which shares characteristic opinions of the group among all engaging groups on the discussion. Other group information can work as stimuli or clues to make us aware of the different discussion routes, like this image. Okay, this is the Airbus system overview we developed. Discussion speech are recognized as text or sentence by speech recognition function. The system server analyzes the text to the word coherence information. And then the system visualizes network diagram from the information and suggests to the discussion group. When the system makes the network, adding other groups' words as stimulus words into the network, we can recognize other groups' discussion information from it. This is a discussion environment pictures. The picture on the right side, discussion people have the tablet PC and the network diagram is visualized on the tablet screen. Okay, this is an example of word coherence network system visualized. Word nodes have 4 colors. White nodes are normal words. Red ones are positive words. Blue ones are negative words. Yellow ones are stimulus words that are additional other groups words. And green nodes are words added latest. We decide the color by the Japanese sentiment dictionaries. It is the aiming to give the awareness that your discussion tends to positive direction or negative directions. It is an English translation sample image, but the system supports only Japanese now. In this discussion theme is AI and elder care. And the system suggested stimulus words, family and burden. From these stimulus words, the people recognize that it is hard for their families to care for the elderly. This is a screen example movie. The screen gradually visualizes the network diagram from discussion speech text like this. Considering the visibility, we define the threshold like one node has one edge, like this. Well, this is the function for the selection of stimulus words in the system. Basically, the stimulus words are decided by word frequency. First, extract top K words from target group A in this picture. In second, calculate the rate of the red line words to some count in other group and find out the minimum rate. And then we regard the group with minimum rate as the group which contains stimulus words against the target group. Finally, select the frequent word which is not appeared in target group from group B. By this selection processing, the stimulus words are appended to the network diagram. Using this system, we held a system experiment. We divide 20 people into 5 groups within the 3 groups which visualize stimulus words, and the other two groups which visualize only one self network and do not visualize stimulus words. Discussion theme 1 is AI systems that prevent the school bullying. Discussion theme 2 is AI and national security. Discussion members are shuffled in every theme. From this experiment, we evaluate our system in that how stimulus words affect the variety of the discussion. Based on the transition in stimulus word count, we focus on the discussion group that adopt stimulus words into the discussion. This is the experimental result of discussion theme 1 and group A3. In this group A3, the system suggests the stimulus words environment and family from group A2. And then group A3 adopts the words environment and family into their discussion. And they made an opinion like that. The family environment is also an important factor in school bullying. Okay, this is the experimental result of discussion theme 2 and group A1. In this group A1, the system suggests the stimulus was self-driving and drive from group A3. And then group A1 adopts the words self-driving and drive into their discussion. And they made an opinion like that. The responsibility of self-driving accidents has a similar problem to AI weapons. Where I evaluate each group's diversity of the discussion based on the word complexity. The word complexity is a measure that evaluates variety of dialogue. It is represented the value that the unique types count of words divided by the sum of all words. We use this word complexity on evaluation because of easy to calculate and does not contain subjective evaluation. And figure 5 on the left side is relationship between discussion time and the word complexity of discussion theme 1. And figure 6 on the right side shows discussion theme 2. In this picture, the red line is a group A, which is suggested as a group's word, and the gray dotted line is the group B, which is not suggested as a group's word. In this result, the groups which are suggested stimulus words keep the high word complexity in the latter time. This result shows a group used many varieties of words in the discussion, and it shows possibilities that they can discuss based on various ideas. Results of experiments suggest that the system works effectively on the point of a variety of discussion. However, we found several limitations of the system from this experiment. The first is limitation of stimulus word selection. And second is limitation of the suggestion by screen visualization. In the first, limitation of stimulus word selection, basically, we decide the stimulus words based on the word frequency, like previous slide of selection of stimulus words, like this. In this example, the stimulus words are family and burden. The words family and burden reminds us it is hard for their family to care for the elderly. However, if the system has selected group C as a minimum rate group, and the system picks up stimulus words from group C, the system may pick up words machine and man. In this case, unfortunately, man is similar to human and machine is similar to robot. There's no good awareness. In second limitation of the system is limitation of the suggestion by screen visualization. People tend not to look at the system screen when concentrating on the discussion speech. In this case, the people could not be aware of the new information system provided, and also cannot be aware of screen changing. The first problem, limitation of stimulus word selection. To improve the function of other group word selection, we are now developing on using neural language models such as word2vec and BART. We use word embedding and word attention value from the language model and visualize the distance of the discussion sentence. This is an example of word attention network we developed. The node position is set by word or sentence embedding. The network edges are visualized based on the attention values. And we can cluster the node based on embedding and the network structure like this. From this word attention network, we think about selection by the word embedding distance. First is calculate the average of group X sentence embedding. And second, calculate the distance from average point to other groups cluster. And select the cluster which has maximum distance. Because of this, we can receive other groups information which is different from our discussion. The second improvement we are thinking about is using another suggestion form in addition to the existing visualization method. One example is implementation of the communication robot in the physical space. Another one is the implementation of the character agent in the screen, and the agent tells other groups information. By using this communication robot and character agent, the system provides the information with voice. Okay, in the conclusion, we introduced the Airbus system that is developed for giving the awareness of diverse values, ideas, and the perspective. We designed the system that supports the group discussion by visualizing the word co-occurrence network and opinion sharing in the network. In future work, we experiment using neural language models and implement of the agent-based suggestion by the communication robot and character agent. And then we evaluate the system on subjective and objective evaluation. Okay, thank you for listening.